Continuity. What is continuity? When we can say things are continuously happening, there should be no break. If there is no break, for example, morning our school break is skipped. What you will say? The fourth period teacher to the fourth period teacher. Sir, morning onwards classes are continuously happening, sir. We are not even having breaks, sir. Which means things comes one after another. Okay. Suppose 5 period is happening without any break. What do you say? Exhausted. That exhausted. Probability. See, this is our first period. This is our second period, third period, fourth period, fifth period. How our school is happening? See, first 3 periods classes will happen. After the third period, we'll have one small break. After that, we'll continue with the fourth period, fourth and fifth period. Okay, third period to fourth period, there will be a gap. Okay, see, without this kind of break, anything is happening. Like instead of this break is skipped, 1 to 5 periods continuously happening. 1 to 5 periods continuously happening. Then that kind of function is called as continuous function. On graph, on paper, it may be easier so that we can verify this whether it breaks or not. Is it possible to verify the same on a calculation? No. So, see, these are all values of x are in x-axis, and when there is 1, this is f of 1. This 2 means here f of 2. And from 1 to f of 1, this is image of 1. Remember functions we are seeing. Image of 1. Is there any image exist for this value 3.5? For this 3.5, any value exist or not? In this case, it does not exist. Okay. Given a point, if the image of the function exists, then we can say the function is continuous. So, in the point 1, is this continuous or not? In point 2, is this continuous or not? Point 3.5, is it continuous or not? Okay. See, that brings us to the definition of continuity at a point. Continuity at a point. Which point? Given a point x equals a, in this point we have to make sure the function is continuous. That how we will say it is continuous? The definition for the continuity is limit x tends to a, f of x equals f of a. See, as I checked here, as I told you here, the point 3.5 does not possess no limit. So, the point given point A is 3.5. When x approaches to 3.5, from the here only it is moving, right? First period happens, second period happens, like this. From x approaches from 0 to 3.5, this function also should approaches to where? F of 3.5. Okay. If the x approaches to 3.5, but this f of x does not approaches to 3.5 means it is not continuous. Okay. In this case, it is not continuous. See the above graph. This is the value of x. It goes and goes and goes on, starts from 0, reaches to 3.5. So, as x tends to 3.5, x tends to 3.5, whether this function goes to hello madam coach காதீங்க கிளாஸ்ல இருக்கேன் நான் முடிச்சிட்டு நான் உடனே கூப்பிடுறேன் ஓகே மேடம் ஆன்லைன் கிளாஸ் Okay. Am I audible? Where was I? This above graph. As x approaches to 3.5, this f of x approaches to f of 3.5 or not? Yes, man. It approaches to f of 3.5. Limit exists. You understood or not? Yes, it is continuous. Here I gave you the example for not continuous. Now forget this. See the above graph. Instead of this, the graph goes like this, means we can say the function is continuous. Understood or not? But now it is very important point we are moving. You know what is continuous, what is discontinuous. Also there are theoretical definitions also is there, like epsilon, delta, everything. That and all will confuse you. Just keep up to this itself. Okay. Instead of this point 3.5, I am telling some point A. Then the definition will work or not? Limit x tends to A, f of x should goes to where? F of A. Then in this case it is continuous, and this case it is not continuous. But sometimes it is difficult to check whether in this point this passes to a limit or not. By that time we will split this as a two limits. How we are splitting? By taking a neighborhood. Neighborhood. What does mean by neighborhood? Whom do you call your neighbor? Nearby area. Okay. Nearby house are your neighbors. Suppose your friend is somewhat far away, a reasonable distance, for example 500 meters. He is also your neighbor, but based on the radius you are taking, likewise we will define a neighborhood for this point A. How we will define? Not that much long. Okay, very small neighborhood, as small as we can. Very small neighborhoods. So A minus h. A minus h means that h is like 0.000000000000001. Very small. Like this, very small. Okay. And this side it is A plus h. For instance, if you take this point as 2 means this point is 1.999999999, and this point is 2.0000001, and that brings us to the definition called left hand limit and right hand limit. Left hand limit and right hand limit. So this limit itself has been split into two. Limit x tends to A minus f of x should be equal to, here I will write limit x tends to A minus f of x should be equal to limit x tends to A plus f of x, which is equal to f of A. F of A means what? This one, x tends to A, f of x. This alone has been split into two. Okay, understood or not? This A minus, before we took no, this is called as left hand limit. This is called as, and here it is called as right hand limit. Left hand limit is equal to right hand limit. Clear? We say a function, it is continuous at a point if limit x tends to a, f of x equal to f of a. Suppose in this manner, if the limit cannot be evaluated, the function passes to 2 or 3 values, then we'll have this definition. Okay, left hand limit should be equal to right hand limit should be equal to f of a. Clear? Any doubts in this? Continuity at a point. See, here I said a minus h. Now we will define what is left hand limit, what is right hand limit. Left hand limit means limit x tends to a minus f of x, that is equal to limit h tends to 0 f of a minus h minus f of a. What is this? This a minus h, I said h tends to 0. When h is tends to 0, h is 0, what does that mean? H is 0, there is no neighborhood. So the distance is nearing to that point A. This itself we took very small value. When that distance becomes 0, the function will reach to A. Is it or not? So that is why h tends to 0, f of a minus h minus f of a. What is that? Simply the distance formula. At this point, this a minus h point, the value of f is f of a minus h. At this point, it is f of a. This distance we are calculating. x2 minus x1. Clear? Clear or not? Little bit. I'll summarize these things once again. Now, can you guess what? What will be the right hand limit? Limit x tends to a plus f of x. Meaning what? Limit h tends to 0, f of a plus h minus f of a. Okay. This is the formula for right hand limit. Okay. Yes, write it. These formulas are not in your book. You finish writing this fast once again and I will explain everything. Still there are some definitions of A in 2 also there, but we'll stick on to this itself today. That is enough. Tomorrow we'll start solving the questions. Okay. Okay. Now, let me summarize everything at once. See, we have discussed about the thing called continuity. Continuity for whom? For a function. Continuity for a function. When a function is said to be continuous, if the graph of the function is not having any break. How do we make sure, how do we check whether the graph of a function has break or not? There are several cases. In that, in particular, at one point, how we will check? In particular, at one point, how we will check means, that brings us to the definition of continuity at a point. Consider the function f of x, and the graph of f of x goes on like this. Okay, the value of x is again and again resubstituted and the images has been formed. This graph has been generated. In this, x value, it starts from 0. It reaches to the point A. When x reaches to the point A, this f of x also should reaches to f of a. Okay. It turns out that the teacher is teaching on topic. He reached to the particular point. The student, he is student 1, he is student 2. The student 1 still got stuck between something else behind. But the student 2 is following the teacher and he is also at the same point of where the teacher is discussing. Understood clearly? Clear? Same way, when x is going somewhere, this f of x also should follow. 1 means f of 1, 2 means f of 2, 3 means f of 2. Likewise, it approaches to a, this also should reaches to f of a. Then it is called as continuous. That as a definition, how we will say means limit x tends to a, meaning what? X approaches to a. F of x. In this f of x, x approaches to a. Then where this f of x will go? It will go to f of e. Then only we can say it is continuous. Understood or not? This one we have written in the notation form. That is all. Also, in some of the cases, it may not be figured out again whether using this definition we can't figure it out. We can figure it out either way, but it may be tougher. By that time, there is another definition, like this limit itself has been split into two parts. One is left hand limit, another one is right hand limit. So, instead of checking directly at this point, usually the x starts from here to reach there, right? Instead of that, we will make the x to start here. At a minus h it will start. So, f of a minus h minus f of a. And that distance h tends to 0. When h tends to 0, this will reach to where? A. X will reach to yes. For example, I kept that in middle. It may be in the middle or somewhere in the graph. Okay. Okay. That is how this continuity works. So that is left hand limit. Right hand limit means same thing, but from that side of the point. Left hand limit means from left hand side we are approaching towards the point. Right hand limit means from right hand side we are approaching towards the point. So while we are starting here, from starting there, both should reach to one place. That both should reach to one place. Then that final image should be equal. Left hand limit should be equal to right hand limit. If in this three equation any one is not equal also, we say the function is not continuous. Understood or not? Okay. These are all the formulas. This is what continuity is all about. But when we are working out, I'll give you some shortcuts. Don't afraid that this much concept is this much complicated. It may looks like complicated, but once if you understood means it is not that much complicated. Okay. Yeah. You just go through all these topics, all these concepts what we are discussed tomorrow. So what concepts we discussed today. Tomorrow we'll add some more to it. Some more contribution will be given to this. And after that we'll start solving the questions. Clear? Okay. Tomorrow you have to tell me all these things. Okay. Continuity, man. There are types of continuity are there. Also some several formulas also there. Those things we'll discuss tomorrow. In the meantime, while preparing, if you have any doubts, you ask me. Okay. Okay, then I'll see you tomorrow. Tomorrow also same time. Okay. Okay, then that is enough for today. I'll see you tomorrow. Bye bye. Any doubts on this? Why don't you ask it right now? Because you're tired of this continuous X approaches. Okay, then you'll revise everything and ask me. Just mark it out all the doubts and ask me tomorrow. Okay. Then I'll see you tomorrow. Yes, sure. You want me to post for it? Screenshot? Take a screenshot. Okay, good. Then revise everything. I'll see you tomorrow. Bye bye. In this session, I have explained what is continuity means. I hope this helps. If you do have any queries or any doubts means, you do let me know in the comments. I'll see that and then we'll discuss in the next session. Okay. Thank you.